Okay, hello and welcome everyone. Thanks for attending this talk on the JBoss Polyglot Revolution. So, just to start, in this talk today you will find out first of all how JBoss became a producer of multi-language platforms. And to understand a little bit how we reached that stage, we'll look first of all at the evolution of JBoss middleware from the years. And if you're interested in any of the language we're going to feature today, then you'll find out how to get involved. So my name is Galder. I'm a JBoss R&D engineer working at Red Hat. I'm a founder and lead of Escalante, which is an Scala application server we're building on top of JBoss AS7. And I'm also working on the Infinite Span project, which is a data grid and caching project from JBoss. I've been developing Java applications for over 10 years, but in the last 3 to 4 years, I've been expanding onto other languages such as Scala, Python, and Ruby. So I do consider myself a kind of a polyglot, both with spoken and programming languages. And here you can find some of my different skill levels. Obviously, don't talk to me in assembly because I don't understand. Finally, if you want to find out more about myself, just follow me on Twitter. So the aim of today's talk is to kind of get you involved into what we call the JBoss Polyglot Revolution. And to get to the point, we'll first look at the origins of JBoss as a Java middleware producer. And then we'll see how this revolution started and the different stages it's gone through so far. Finally, you'll find out how to be part of the JBoss Polyglot Revolution, either as a user or a contributor. So let's go back in time a little bit. Back when JBoss started, it pretty much developed Java-related middleware, Java middleware. But why was the reason why JBoss decided to use Java and why not other languages? And that was because Java was really the first language suitable for large development teams with a large-scale deployments and that needed applications and whose applications were going to be accessed by quite a few users. Obviously, Java provided a very perfect combination of, first of all, virtual machine execution, so it meant that you can run your application in any platform independent on the code that you wrote. It also came with automatic memory management, so it meant that you don't need to worry that much about memory leaks. You still need to, but it's a bit of a safer environment. It also had static typing, which meant it was much easier to provide IDEs and things like that, tooling around static typing. And finally, it came up with a very readable syntax. So JBoss's first offering, which was called JBoss, which was first released, I think, in 1999. Obviously, JBoss standard for an open source EJB server, but obviously, due to copyright reason, etc., Sun decided you cannot use EJB, so we had to drop the E. We ended up with JBoss. If you like to go back and look for things on the internet, you'll find, I think the earliest source code you can find, I think is version 0.04, which I think it was the first public release, so there's some interesting code in there. Over the years, JBoss brought in a lot of other projects into the ecosystem, primarily in the Java space. So it brought Tomcat, which integrated into what we call JBoss Web today. He acquired Hibernate, JBPM, JGroups, transactions, rules, a lot of them. All of them within the space of Java. Over the years, however, the popularity of Java has gone down, and that's very clear looking at the following graph. This is shows you a little bit the peak of Java as a language for what they call the Programming Community Index back in 2002, and slowly it's gone down in popularity. What's happened is, as the years have gone by, new languages have come up, such as Ruby, Python has evolved. You've had Scala, Objective-C, etc., many others. There's also been what we call an explosion, a developer explosion. It's been on one side, back in the early 2000s, everyone had a computer, and that was pretty much what everyone used to communicate with each other. But in the last few years, the amount of devices that have to connect with each other, or they have to work with each other, has expanded massively. So you've got anything from iPhones, iPads, domotics in houses, etc. But regardless of where you are, these days, any enterprise is having to build some kind of integration layer for all these devices, or web browsers, etc. And then it's having to do develop applications, it's having to run them in some kind of infrastructure, it's having to manage the applications and the devices to make sure they talk to each other fine. And it's also having to integrate all of these devices with back-end enterprise systems, whether these are databases, web services, etc. Now, what we think is that the JVM is by far the best virtual machine out there for creating these integration layers. Now, going back to what I said before, why do we need a VM? Well, the reason is because these days we don't really want to be coding against a Windows platform or a Solaris platform or a Linux platform. We want to be able to code and be able to run independent of the platform. We also want to be having a code base or a code that is safe, we're not going to be having to worry that much about garbage collection and things like that. And the cool thing a little bit about the JVM itself is that it's a very, very versatile platform where you can run pretty much any language on top of it. And this is probably one of the best decisions that Sam did at the start. He made a virtual machine that could run any language that could convert into a binary class file format. So it means that as long as you have a language which you can convert it to it, you'll be able to run it on the JVM. Obviously, back in the early 2000s, it was just Java, but as we'll see, things have moved on. So I think that the JVM is literally the best virtual machine out there for running any language that you want. Which languages do we have these days? We have things like, we have languages that have been kind of adjusted to work on top of the JVM, such as Ruby, which obviously had its JRuby implementation created to run the JVM. We have Python, which also has had a Jython implementation. But over the years, there's also been a load of other new languages created exclusively for the JVM, such as Scala, Ceylon, or Clojure. Now, regardless of the languages, whether you are a user, whether you are a consumer, whether you are a customer, there is still a need for these languages to have certain requirements. First of all, they need to be able to interoperate with Java. That is because if you start writing, I don't know, in Ceylon, you're not going to drop your Java applications at all. You want to be able to work with Ceylon and Java probably within the same JVM. You probably want to use different languages in different ways, where you layer them so that you take advantage of them at different stages. But there's also other interesting requirements. You still might want to use message delivery, maybe guarantee of message deliveries. You might still want to use transactions, which might not be ACID or not. You might want to do audit trails, security, etc. So a lot of these capabilities are kind of enterprisey. So if you're faced with creating a brand new language, you either have to build them from the scratch yourself into the language, or you can actually leverage what other people have done. Okay, and this is a problem that Java did have at the beginning. At the beginning, when it started Java back in '96, there was J2E was not there, so there wasn't any transactions or messaging or anything like that. So obviously, as J2E evolved, Java was able to take advantage of those capabilities. So these days, given the choice, building from the scratch, I don't know whether it really makes that much sense. And this is one of the things that Bob McWhirter thought back in 2008. Bob, who joined JBoss, I think, in 2007 or so, he had been running JBoss.org. He also created Groovy language, which is a language for the JVM. And he decided that in this year to go back to development. Now, the problem is that he loved Ruby on Rails. So how many of you have used Ruby on Rails in the audience? Okay. So back in 2008, when Bob wanted to develop some application in Ruby on Rails, he found out that Ruby on Rails was great to develop applications very quickly, But unfortunately, some of the things in Ruby on Rails were less than ideal, okay? Deployment was it didn't work that well. It also had, Ruby on Rails required some admin procedures at the time as well. You need to do, if you wanted to do some scheduled jobs, you had to do cron tabs. And around the same time as well, Twitter was kind of quite worried about the scalability problems of Ruby on Rails, and it actually decided to ditch it. So Bob, faced with this solution, he said, well, how can I make this better? How can I make Ruby on Rails applications better? So what he did, he took JRuby and decided to layer it on top of JBoss AS. So what he did with that is basically be able to take the services available in the application server at the time, such as messaging, clustering, scheduled jobs, caching, etc. And he was able to provide them to the Ruby on Rails applications. And he did that in a way where it could run on top of the JVM. At the time, if you remember Ruby on Rails, you had different VMs for different machines. By running on the JVM, he was able to do it in a platform-independent way. On top of that, he was able to make some cool things for Ruby on Rails users. He was able to deploy them natively without the need to create any wars or anything for the app server. And it didn't need any caching server anymore. He was able to use, if he needed to do any caching, he could use the caching server, the caching service within JBoss application server. So out of this experimentation, that's where Topbox was born, which basically was the result of trying to deploy Ruby on Rails on top of AS. Now, ever since we at JBoss, we've been working on making the JBoss application server not only the best app server for EE applications, but also for any language that can run on top of the JVM. Now, if the J2, there's been a quote of a phrase over the years where they say J2E is bloated. I mean, I want to be using a Spring or other kind of applications. But to everyone that thinks that J2E is bloated, I would say, well, you need to differentiate between two things here. One is the spec, which obviously JBoss doesn't control, and which we might think, okay, it might be bloated, but is it the spec? We need to support it. But the implementation that we do of that spec is up to us, okay? And I know if you've been using JBoss in the past, we know that with AS5, AS4, AS6, things were not ideal. But with AS7, we went back and said, we're going to create a foundation that people can use and that they want, that is lightweight, enterprise ready, and that people are going to love and easy to test. So with AS7, we basically restarted a revolution around the app server. But the app server that now I consider it to be not just an EE server, it's a powerhouse, okay? We have at the core, we have a lightweight system with modular class loader, very defined services that run on top of it, such as you've got Hornet Queue to provide you with messaging, InfiniSpan to give you caching, data grid capabilities, CDI integration, access to JVPM to do your business processes, etc. And then what we've been doing with the Polyglot Revolution is, okay, take what Bob did with Torquebox and Ruby on Rails, and we've been expanding on top of this powerhouse or application server in order to enable more languages to benefit from the capabilities we have inside the application server. So which are the different communities or endpoints we've been working on top of the application server, and how can I get involved with them? On one side, we've got what we call the language implementation community. These are communities within JBoss that are working together with the language communities in order to provide first-class implementations of those languages. On one side, we've got JRuby, which joined JBoss just a few weeks ago, where Charlie and Thomas are basically managing the Ruby implementation for Java. And we got as well, I don't know whether you've heard already of Dean.js, which is a brand new JavaScript implementation for the JVM, which is using invoke dynamic operations in order to speed up the execution. Both of these, and all these, obviously, with all the source code at JBoss, is open source. Okay. we go to the middleware side, we've got Torquebox. Torquebox is still going very strongly. What we're doing is we're trying to go beyond the basics of what Ruby offers, being able to offer you message-driven Ruby objects, scheduled jobs, services, infinite span-based caching, and clustering in general, allowing you to failover and do high availability. We've also been working on an active record implementation, which allows you to not only store to infinite span-based data grids as opposed to the database. So things that Ruby users can do on top of Topbox are things like async programming using messaging. What I call that is basically the ability to have backgroundable tasks which work a little bit like Java features. So that is, you submit them, as a return you get a feature, and then based on the feature you can see whether they've been completed or not. As we see in the example here where we got a flying car, which really what we're trying to do is recharge its batteries. And then what we're trying to do is submit a task to recharge the batteries, and then see whether the task has finished. In terms of Topbox itself, currently there is a version 2.1 out already. So given that it started in 2008, you might think it's a fairly mature project. I think at the Ruby, the part that is the Ruby interaction is a very mature. The underlying app server, it has gone through several iterations because it started with AS5, AS6, and now it's in AS7. And I think that's the primary work they've been doing. So I consider Topbox to be fairly mature at this stage. Another community within the JBoss Polyglot group is what we call Immutant. Now, how many of you have used Clojure? 3, 4, 5, 6. Oh, more than Ruby. Interesting. So effectively what we're doing with Immutant is provide an application server for Clojure applications. What we're doing is very similar to what Torquebox did. That is, take advantage of the services provided by the application server and expose them up to Clojure applications. This includes things like asynchronous messaging, caching, XA transactions, clustering, etc. And quite importantly, we're also integrating with Lane, which is a very popular build tool within the Clojure community. Another cool thing of the application server that Clojure is taking advantage of is the fact that when you start AS7, it can start with bare metal, with the bare minimum services you need to start. And then as applications are deployed that need, I don't know, the web services. The web services also started, so we can start services with the application servers on demand. So what we're doing with Clojure, for example, for Clojure applications, is enabling dynamic service binding via code. So this means that if the web service is not running when you run this code, then it's going to start it up first of all, the web server or the web component, and then it's going to be able to serve this application. Immutant, contrary to Topbox, is quite a bit in its infancy. I think Immutant started about 9 months ago. So at the moment they're on their 0.6 release, but they're moving very fast. They're building a lot of cool things on top of it, and I think there will be a 1.0 release in the next few months. Something that I've been working on, and I think a lot of people in this conference seem to be keen on, is in a Scala application server on top of AS7. Now, how many of you use Scala? Okay, so that's about 8 or 9. Okay. Now, unfortunately, I still don't have a lookup, but I'm hoping to get one in the next few weeks. Now, what is it that we're trying to do for Scala applications? What is it that I think AS or the JBoss application server can do better? The first thing that one of the first things I've been looking at is Lift. Lift is a web application framework for the Scala world. And one of the things that is quite curious about Lift is that if you try to deploy the Hello World application, that takes about 31 megs. And you think about it, 31 megs to deploy a Hello World application. Why is that possible? That is because when you deploy the Lyft Hello World app as a war, it needs to contain all the libraries that it needs. So that means the Scala libraries, the Lyft libraries, etc. And the Scala libraries tend to have a reputation for being quite big. So it's easy to end up with an application that is 31 megs, even though all it's saying is Hello World. On top of that, this actually has a memory consumption, as we'll see later on. If you try to deploy this application on top of AS7, it'll come to about, I think it's about 50 megs when you have a look to it on the JVisual VM. On a heap time, it was showing about 40 megs. Now, what I've been trying to do with Escalante, which is the Scala app server for the app server for a Scala application, is trying to make, one of the first things is trying to make Lyft applications nicer to develop and deploy. And one of the things I've been able to do is I've been able to get the same Lyft application, but that only has 8 kilobytes to do the same thing as the other one. Now, by reducing, what I've been doing here is able to, instead of you having to ship me all the libraries that you need, tell me which versions of the library you need. And based on that information, I'm able to do dependency resolution and be able to bring them into AS. And what I'm able to do is something very cool. I'm able to install them as JBoss modules within AS in such a way that I can run multiple applications within the same app server. So it means I can have a Lyft application that uses Scala 2.9, and I can have another one that uses Scala 2.9. I can bring them in, install them as JBoss modules, and each of them will be class loader isolated, which is one of the cool things about Escalante. But it's not just Lyft users that are being made happy. Cloud users are also happier with using Escalante. That is because clearly it's going to be much easier or much quicker to deploy or upload an 8 kilobyte file compared to a 31 meg file. And in fact, this is something that OpenShift, which is Red Hat's cloud offering, is already taking advantage of. You have here a link to one of my posts where I explain how you can use, if you are a Lyft user, how you can use Escalante on OpenShift. And finally, one of the interesting things before is I was saying, if you take the first application and you deployed it, I think it was consuming about, on JVisual VM, it was showing a consumption of about 50 megs, and then the heap dump about it was 40. So actually deploying a smaller WAR results on less memory consumption. So what I'm doing with Escalante is reducing the size of your applications, of the deployments, making them consume less, and making them more cloud-friendly. Another thing that I've been working on recently with the Vaadin community has been integrating Escaladin into Escalante. Escaladin is essentially a Vaadin Scala wrapper. And what is it, Vaadin? Well, this is a very short intro, but in my next talk after this is precisely given by Jonas Lenningen, which is the CEO of Vaadin, which is going to be explaining more about Vaadin itself. But to give you a brief overview, essentially what Vaadin does is give you a UI that has been, web applications whose UI has been generated using GWT. The cool thing about it is neither at runtime, neither on the client side, you have a GWT dependency. And it makes for very fancy looking web applications. Finally, to finish a little bit with Escalante, Escalante is quite in its infancy so far. I've done a 0.1 release a couple of months ago, but I've got more cool things coming up, including obviously integration with SVT, which is a simple build tool, a very popular build tool within the Scala community. I'm also have got some support for Play coming up as well, so that's going to be some interesting work that I'm going to be doing. Obviously, either me or me working on Escalante or any of my friends, colleagues working on other projects, we're always looking for, if you have an interest in a particular language, obviously using this kind of middleware is interesting, but also if you want to contribute to it, if you see any bugs or things that you would like to see, then we're always welcome to your suggestions. Moving on, next I wanted to talk about Yellowbird, which we also call as.py, which is basically our attempt to run Python on top of the JBoss application server 7. We are having a few problems actually with this. That is because, whereas if you remember when I was talking about language implementations, what we're trying to do with JRuby and Din.js is make sure these implementations are a first-class citizen so that every application that runs on Ruby can run on top of JRuby. Well, with Python, which is the Java implementation of Python, things are not as smooth. What happens is the Python implementation until now has been a little bit marginalized in a way. So it's not really quite a first-class implementation of Python. So a lot of the applications that run on top of Python these days, they assume a C-based implementation, which kind of makes things a little bit awkward. As I said earlier, we've got a brand new JavaScript implementation coming up, which is called Din.js, and we also have got a middleware around it coming up as well, which so far we've called it as Jazz. So what we're trying to do here is pretty much the same. Take existing JavaScript applications, particularly oriented to those now running on top of Node.js, and then make them run on top of the JBoss application server, and then take advantage of the middleware we provide. If you went to Teams talk yesterday, what we're doing here is very similar to what Vertex is doing already, but the advantage that we have here is we have an application server underneath with all its capabilities that it comes with. So we have clustering built in, caching built in. If you probably want to do that in Vertex, you're going to have to bring in another libraries to do all these kind of jobs. So you're going to have to do quite a bit of integration yourself. Finally, one of the kind of last effort, another recent effort we've been working on is something called Ceylon, or Ceylon. I'm not sure how you pronounce it, but I'm sure I'll be corrected by Gavin if I say it wrongly. Ceylon is essentially a brand new language for the JVM, and you might be wondering why is it that isn't there enough JVM implementations, JVM languages out there? I think the Ceylon has got some particular goals that are very specific to what they're trying to achieve. On one side, they're trying to come up with a powerful static type system. The reason being because they want to have things like union types, intersection types, and things like that into the language, and they want to be able to express more easily, really. They also believe that we spend more time really reading code than writing. So readability of the code should be something that should be prioritized in Ceylon. We're also working on a predictable compiler so that we follow simple rules, intuitive rules, and we have meaningful errors. And for me, one of the key things that I like about Ceylon is the fact that they've been working on the modularity to be embedded within the language. What this means is when I create an archive of Ceylon, I'm going to be defining what is it that I'm going to be making public out of it. And I'm going to be defining as well what is it that my dependencies are. So it means you don't need to start like using Maven or anything other to figure out what your dependencies are. The archive itself should be able to tell you exactly what my dependencies are. And I think that is really good. Being able to do that from within the language is something that I think is very, very useful. And something else that the Ceylon guys have been working on is on tooling. And that is because once you have a static typing, building tools around it is much easier. So if you download Ceylon today, you'll be able to get a big command line toolset, and you'll be able to use also the Ceylon IDE, which is an Eclipse-based IDE, which comes with search, refactoring, etc. And now, if you want to find out more about Ceylon, there is at 2 p.m. Gavin King is going to be giving a talk today, so I highly recommend that you attend that. So, having looked at where JBoss started and all the communities that we've created around the middleware, I think these days, whereas in the past the J within the JBoss name standard really for Java, I think these days we're going beyond that and we're trying to say, hey, this is an server for the JVM, not necessarily Java, not necessarily Clojure, but something for everyone. Okay. To finish, I wanted to give you some links. Obviously, if you are a Clojure user, a Scala user, if you are a JavaScript user, Python, if you want to try our things, these are the websites you should be heading to. And not just that, in these websites you will find everything from quick starts to download instructions, but also how to get in touch with the development team. All of these, pretty much except Topbox, the rest of the communities are very, very young. So if you are interested in being part of open source and contributing, this is a great opportunity to get involved, because these guys are just getting started. So we are actively looking for contributions. If you're running any of the servers here, you see an error and you want to contribute or help us with fixing it, we think it's a great opportunity for you to do so. And just my final slide for the day is I wanted to show you this quote, which is from 1968, given by Richard Hamming in the Turing speech, where he basically says that the central or the biggest problem that computer science has these days is figuring out how we can take the things that we've already built and use them together, rather than keep reinventing things all the time. And this is something that here at JBoss we really identify ourselves with. We think that by taking what we've already produced, we can build more cool things on top of it. There's no need to reinvent what we've already done. I think I still have about 20 minutes. So in the next 10 minutes, since I have a bit of time, I wanted to show you a little bit something that related to Escalante. So let's go back. Oh, it's in mirror already? Okay, cool. All right. Actually, it's not. Okay. Can you read that? What you see there? Yeah? Okay. One of the coolest, so what I wanted to show you a little bit is how, for example, how do I do testing in Escalante? For that, I wanted to show you one of the coolest things that has come out of JBoss in the last few years has to be Archillion. Archillion is basically a test framework that allows us to test applications within the container. Now, if any of you has ever used Lift, for example, which is the web development framework for Scala, you'll hear them talking about, well, the testing, you should do it using mocks. So you should kind of build this mock that kind of represents the container, and then you should test against it. I'm like, well, why should you be using mock when you've got something as cool as Archillion? Archillion gives you the ability to test within the container, which gives you much more confidence that once you've tested with Archillion, your thing is going to work fine when you actually deploy it in the server. Now, what I have here is a very typical example of what I explained about Escalante. One of the things I want to do with Escalante is being able to deploy multiple applications that might be using different Scala versions. So what I'm doing here is testing the typical Hello World application. And what I'm doing here, I have 3 different deployments there. One that is going to use the default Scala version that I use, which is 2.9.2. And then I have 2 others that are going to be using a different Scala version. The idea is that when these tests run, those 3 deployments are going to be deployed, and then each of them is going to be basically checking a hello world, whether the hello world message is returned. A very, very simple example. Now, how does each of these deployments figure out what is the Scala version that I need? It does it by providing a very, very simple deployment descriptor. This is very temporary at this stage. It might not be the final thing that I end up using, but it is what I'm using at the moment. So let me show you where the deployment gets created. So here is where we build in the archive. In this line here, what we're doing is we're using something called shrink wrap. Shrink wrap is a tool for creating archives. So it could be a jar, a war, any type of archive. You can create it with shrink wrap. And then what we're doing a little bit further down is create a very simple lift XML out of the dependencies that we got. So what we're doing here is we're getting a lift or a Scala version, and then based on that, we're basically injecting it into the deployment descriptor. The deployment descriptor then passes on, is what tells the Escalante server what is it the Scala version that you need to be running. So let's see this a little bit in action. So what I'm doing, first of all, the Archelian starts the application server, first of all. Then when it starts doing, it starts creating the 3 different words that it's going to need. And then it starts deploying each of them individually. And then what this is showing me several things. One, obviously, that my Hello World application works. Second, that I can deploy actually multiple versions of a Scala app in parallel, and they all work fine. So what we're seeing here is how the first one has been deployed here. Let me see once it finishes. And once it's deployed, it starts testing each of them individually. Okay? So to show you a little bit how it happened, the first application that it ran was the Hello World default one, which by default uses a Scala 2.92. And then it went down and deployed the next one, which used a Scala 291. And then the next one would use 290. So what is done here, in this case it hasn't gone to the internet because I already had the jars within it, but because I had the jars already in my machine, it's created modules within the application server for each of these jars, and it's able to plug them into the deployment archive without any class cast exceptions or anything. And then once all of them were deployed, it's basically target them individually to make sure they run fine. And that's about all I had to talk today. As you can see, we've got a lot of work going on different languages. If you are interested, ping me or ping any of the communities out there. And yeah, thanks. That's all I wanted to say. Any questions? Any questions? Yes? The question is whether I showed Ceylon, whether Ceylon has any integration with the application servers yet. I don't think it's there yet. I think there's still, I think the language, I'm not sure is 100% finished. So I think they're finishing with that first. And then I guess there will be some kind of web framework or similar that we'll be working on. And then they will start on the integration with the app server. But you'll probably be able to find out a bit more about Salem if you go to Gavin's talk at 2 p.m. He might be giving you more information about where it is in terms of the language and where they're heading. I think the language is pretty close already. Any more questions? Okay. Thanks very much, everyone, for attending. Have a good day.